So, how do we charge an object? Well, there's actually several ways. One way is we can charge by friction. And if you've ever rubbed your feet on the carpet and then touched your friend who was standing nearby and given them a shock, you have charged yourself by friction. And what's going on here? The rubbing between two objects actually causes one to steal the electrons of the others. Now, it doesn't steal the protons because protons are, well, relatively gigantic compared to electrons. Electrons are tiny, tiny little guys. And so it turns out that just simple rubbing can actually cause an exchange of charge, leaving one object positive and one negative. In fact, this sort of charging happens in cumulonimbus clouds. And these are the sorts of clouds that cause lightning. And what happens is little drops of ice or water are constantly moving around in this cloud. And as these droplets pass through the cloud, rubbing against each other and passing through different regions of the cloud, they gradually either accumulate or lose electrons, depending on what they're moving on and the details of the actual situation. But what this does is it creates a motion of charge. Whether this is positive or negative, whether it's going up or down, it doesn't really matter. What happens is charge separates. And what that usually leads to, this chaotic motion of particles, is a buildup of minus charges on the bottom of the cloud and positive charges on the top. And we've already shown that these minus charges lead to corresponding positive charges building up in the ground. We're starting to really understand lightning here, as well as electricity. So we can use charging by friction to create a charged object. So let's say we've created a positively charged ball. A good way to do that is by rubbing something metallic with, let's say, rabbit fur. Anyways, we have this positively charged ball, and we know that if we bring it near to this ball, we'll induce some polarization. Negative charges on this side and positive on that side. Fine. But what happens if this ball touches that ball? So we bring this over, let them touch, and remember, they're both conductors. So I want to know, what do you think will happen when I touch this ball to that? Do you think nothing will happen? Do you think that some positive charges will flow from ball B to ball A? Do you think that some negative charges will flow from A to B? Or do you think that all of the positive charges on ball B will flow to ball A? Think about what it means for something to be a conductor, and then give this question a shot.